In this question, we're going to focus on some of the evidence that looks at the structure of the atom. We're going to focus in particular at some of the experimental models. It's really important that you know the processes that these experimental models are talking about, as knowing the processes and having that clear in your mind will help you pick up easy marks. So the question starts with, in the early 20th century, scientists developed an alpha particles scattering experiment using gold foil. Figure 4 shows the path of some of the alpha particles in the alpha particle scattering experiment. Explain how the paths of the alpha particles were used to develop the nuclear model. Right, first thing is there are 3 paths that it takes. So you're going to have to talk about all 3 paths. You're also going to have to talk about the physical structure of alpha radiation. So you might start off with alpha radiation is made of 2 protons and 2 neutrons. Because it's made of 2 protons and 2 neutrons, it's relatively large in mass and has a charge of +2. It doesn't travel very far in air, which is why this experiment was done in a vacuum. Then you can talk about, if you start from the top, some of the alpha particles were bounced back. This means that the center or the nucleus of an atom must be really dense, because if it wasn't dense, most of it would either stick to it or you'd find none of it going back. You can talk about the fact that most of the radiation went straight through, giving us the idea that most of the atom is empty space. Some of the radiation was bent away from the nucleus, giving us the idea that the nucleus must have a similar charge to the alpha radiation, so it must have a positive charge in order to repel it. Right, the second part of the question states that Niels Bohr adapted his nuclear model by suggesting electrons orbited the nucleus at specific distances. Explain how the distance at which an electron orbits the nucleus may be changed. Right, all this is just looking at things that are going to raise the electron potential level of your physical electrons. So electrons may absorb electromagnetic radiation. If they absorb that radiation, it's not going to change them from being an electron, it's just going to give them a bit more energy. You might want to go and talk about the fact that if they absorb more energy, that's going to enable them to move further away from the nucleus. And if they're moving further away from the nucleus, that's going to put them at a higher energy level or an orbit that's further out. Right, go back, have a go at this question. Try and really focus on squeezing out as many marks as possible. Keep referencing or keep going back and checking how many marks each question or each part of the question is worth, as this will give you some indication about how many points you'll need to make.